Now, today I want to do a little bit of coverage of Python tools for data science. There is no assignment due for this module. This is just an FYI or sort of get your feet wet kind of a thing. But I think it's a pretty interesting subject area, and it's actually something that I am taking classes to learn more about data science. Yeah, my wife thinks I'm a little crazy after a PhD to want to take more classes, but um, I have more interest than I have time. So anyhow, I think data science in general is very interesting. It's very closely connected with things like machine learning and artificial intelligence and a lot of the really amazing hot topics for today. Um, it's it's somewhere in the middle of like statistics, computer science, and oddly enough, there's some design elements in there. There's a little bit of math, like theoretical kinds of math, um, and just a smidge of like animal training, basically, because that's literally when you are uh, using machine learning, you're actually training a computer in a very similar way that you would train an animal. A little bit more sophisticated, I guess, but um, and much faster. But you know, the big benefit is that your hands don't smell like dog food when you're done or whatever. So no allergies. So data science, Python is the platform of choice for data science. The other platform is a statistical package called R. You might hear about that every once in a while. But when it comes to machine learning, visualizations, all kinds of stuff, Python is just packed full of really good tools. So let's start with the basics. What is data science, really? And data science is the process and the tools for making sense of data. Right? We have lots and lots of data, probably more data than we need in our world. We're always creating data. Every time you click on a link or watch a video, you're creating data. There's data everywhere. Showing up to this class, you're creating data. Logging into Canvas, I mean, we just leave a data trail everywhere we go. Every time you use your credit card or buy gas or do almost anything, you're creating data. And we use that data now to try and make sense of the world around us, to make things better for ourselves. And that's where data science comes in. Because we have so much data and because it comes from all over the place, and quite frankly, a lot of it is imperfect data. Like I might give a survey to my class asking you about your favorite foods, and it might have 5 questions on it. Well, the odds in a class of 20 people that everybody is going to answer every question in an appropriate way is almost zero. Somebody might skip a question, somebody might choose two foods for one of the questions instead of just one. My data is going to be messed up. So part of data science is actually fixing data. So when we start with the data science, we always start with sort of like, what is it that we want to know? What are we trying to figure out? What are we trying to understand? Then we gather the data, and this part here, step number 3, we clean the data. Meaning, if I have surveys that are missing an answer, I have to figure out how to deal with that. Do I make up an answer? Do I leave that person's data out completely? What do I do? So and each one of those choices has implications. If I give that survey to 20,000 people and 5,000 people don't answer a question, what I choose there will determine what my results look like, which means that will determine how I understand the world and make decisions. It might be, what kind of food do we want to serve at BC cafeteria next semester? Pizza, obviously, if you've been there, right? So good. Um, so cleaning the data actually impacts what we do. Then we kind of get a feel for the data. What are the fields? What does it look like? What kind of data is it? We start to build the data structures. We build and analyze the data according to different statistical models. we might do predictive analytics or predictive modeling. BC actually does some of this with your data, and you don't even know it, not on a personal level, but we actually use a predictive modeling algorithm to tell us how many of each class we need each semester. So when we're building, like when we were building the schedule for next spring, we used data for the last 3 or 4 years and student trends and demand, and we saw who took what class and what class comes next in that sequence. And it takes all that into a big algorithm, and it says, here are the classes you need, and here are the times and locations you should put them to best serve students. So it's kind of a cool thing, but it's very, very useful, and it's all based on this sort of data. Data visualization is what we'll talk about next week. On our last lecture, we'll actually get into some visualization tools, but visualization is pretty essential for communicating the results of what you learn from your data, because I could show you a database of 10,000 survey responses. I'd be like, look at this. And you'd be like, cool. I have no idea what that means. But if I show you a chart that shows that 85% of BC students prefer pizza in the cafeteria, that's easy to see. You can't see that in a survey with 10,000 responses, but you can see it if I make a chart that shows you that. So that's what visualization does. So all of these pieces are elements of data science. They're not always used every time, but they are mostly used most of the time. And there are things to think about as we get into data science. So in terms of Python tools for data science, we've got some really good ones. And these are the ones we're going to kind of tinker with or play around with here. Jupyter is a really cool project. And in fact, it is a tool that is used extensively in data science. It's also used quite a bit in teaching Python, and it's something that I'm planning to integrate into future classes a little bit more. I'm going to show you it today and let you play around with it or show you how it works. But Jupyter Notebook and Jupyter Lab actually allow you to try code out in your web browser. And it has some trade-offs. In some ways, it's better and faster for data modeling and for running quick programs and trying things out than PyCharm is. But it also doesn't have some of the robust tools that PyCharm does. Like, it doesn't complete your sentences for you, and it doesn't fill in things. It doesn't show you what methods are in an object when you hit a dot after the object name. So there's certain things that are not as good, but there's definitely a use case for Jupyter Notebooks in data science because it allows you to sort of play with your data. And that wasn't in the data science lifecycle that I just showed you, but playing with your data is kind of part of the deal, getting a feel for it. And that doesn't sound very scientific, but it actually is very useful. So Jupyter Notebook is sort of an environment and a tool that we use for data science. Pandas is a library that's built on the NumPy Python library that extends that mathematical library to cover a lot of really powerful data and statistical tools, so data analysis. So Pandas is what we'll be using primarily today, getting into some of the data analysis and how it works and that sort of thing. Both Matplotlib and Plotly are two different visualization tools. There are advantages to each. I have a pretty strong preference for Plotly. I think the graphs and charts that it creates are much better looking and much easier to use. So when we talk about visualizations, we'll primarily be using Plotly, but Matplotlib is one that's available too, and it's commonly used, so you should be vaguely familiar with it. I think Plotly is sort of the winner, though, when it comes to the best stuff out there.